Hey y'all, sorry I'm out again. Today y'all are getting a new packet. This is what it looks like. Okay, so we're still in Unit 2, but this is the second part of Unit 2, and we're doing inverses. Okay? Please make sure you write your name on it and your period. Okay? Do that now. And then go ahead and flip to the next page. Okay, so pretty much what we're dealing with now is the same thing we dealt with in the first part of the test, except we're looking at the opposite of it. Inverse means opposite. It means opposite. It means, what's the other word? Reverse. Okay, it's kind of like it's opposite. That's the best way to put it. Okay. So now we have an arrows on it. We're going to go ahead and do notes, day 1, okay? So first things we need to talk about is the inverse operations for the following, okay? So it says the inverse operation of addition. So what's the opposite of addition? What's the opposite of addition is subtraction. Okay, the inverse operation of multiplication is division. Now, this kind of goes with what we were talking about opposites. So it says the inverse operation of squared is actually square root. Okay. The inverse operation of cubed is cube root. Okay. Now, this is one we haven't really talked about, and I don't know if you have learned before, but the inverse operation of log is exponential. I had a brain fart for a second. Okay, so there's a couple different ways you can see inverses when it comes to numbers. So you can see additive inverses. So for example, the additive inverse of 3 is negative 3. The additive inverse of negative 2 is positive 2. Okay, so it's just finding the opposite when it comes to the sign. So either pretty much adding or subtracting. Okay. Now the multiplicative inverse is kind of like the opposite of multiplying and dividing. So the inverse of 3 would be 1/3. So multiplying by 3 or dividing by 3. Okay, the inverse of negative 2 would be negative 1/2, okay? So it's kind of like saying you flip the fraction, because 3 is the same as 3 over 1. So we're just flipping it. So it's flipped fraction. Okay. So we're going to talk about how we find inverses in the 3 different representations. Okay, so using tables, the rule is you literally flip the x and the y. Okay, so for example, if you have a table like this, the inverse of this table would be literally the opposite. So negative 2, 1, negative 4, 2, negative 6, 3. So we literally flip the x and the y to find the inverse when we're looking at tables. Okay? Now, equations is a little more difficult. Okay? And don't worry, we're not practicing all of this today. So with equations, if you have an equation like, so you flip the x and the y, again, we're flipping. Then you solve for y. So I'm going to show you an example. So you flip the x and the y, and then you solve for the y. So if we have y equals 3x plus 2, okay, to find the inverse, we literally flip the x and the y. So it's going to be x equals 3y plus 2. Now we solve. So we're going to subtract 2 from both sides. and we get x minus 2 equals 3y. How do we get rid of that? We divide by 3. Divide everything by 3. This cancels, and we're left with, I'm going to flip it, y equals, so remember that's 1x, so 1/3 x minus 2/3. That is the inverse of that. Okay, so when doing graphs, it reflects over y equals x. So if we have a graph, okay, I'm going to draw y equals x. Remember, that's your linear parent function. So it looks like this. It goes like, remember, it cuts it kind of in half diagonally. So pretty much this is flipping diagonally. So if I say that this is my line, my inverse of that would look like this. So let's say that's like 2 away, so it would be 2 away. Something like that. Okay? So that is what it looks like for inverse on the graph. Now, obviously, the easiest way to ever graph them is to build the table of your original, flip it, and then graph your inverse. Okay? We're going to practice all of these methods, not today. Okay? We're going to kind of take it one thing at a time. So, reminders, just little things you need to remember. X-intercepts are when y equals 0. Y-intercepts are when x equals 0. So remember, when you write them as a point, your x-intercept is always going to be a number, comma, 0, while your y-intercept is always going to be 0, comma, a number. Okay? Domain is your width. It's all possible. This should be longer. X values. Well, range is your height. All possible y values. Okay, just a couple things to remember. Okay, so I'm just going to kind of put this up here. Make sure you have all of this bottom part down. Okay, just so y'all know, I will be posting this, the key to these notes as well as this video on my website. So if you don't remember my website, bit.ly/CUMBERLEDGE. Remember, that's just my last name, all lowercase. Or you can literally Google Cumberledge's Classroom, something like that, and it'll pop up. Okay. So hopefully you have all of this down. Okay. So now we're looking at this. Okay, so I want you to go ahead and label. So the way you write inverse versus, or the original versus inverse is like this. F of x, f of -1x. So this is original. This is inverse. Okay, so we'll label each of the lines. This is our original, f of x. This is my inverse, f of -1x, sorry. Okay. Inverse f of -1x. Ew, my son had chocolate, so I just got it on my paper. I don't even know how. Okay. So f of -1x. This is f of x. This is f of x. So all of these tables on the left are our originals. All of these tables on our right are going to be our inverse. Okay. Now it does show you how to graph these. So like, or not graph these, but solve the equations. These are the actual equations to these lines. We're not really doing that today, but this is just good notes to have, so I kept it on there. Okay, so we have this original line. Okay, it tells us the original equation is this. Okay, so we have one of two things we can do. We can pick points off of here, or you can use your calculator to find some points. I'm going to pick points off the graph simply because I don't have a calculator, but y'all should. So here's a pretty point. I'm going to put dots on all the pretty points. Okay, so I'm just going to pick a couple of those. So we'll do 0, 3, 2, 4, 4, 5, 6, 6, and then 8, 7. Okay, so there's our first one. So if I do the inverse, I'm literally going to flip those. 3, 0, 4, 2, 5, 4, 6, 6. That one stays the same. 7, 8. So let's check it. 3, 0 is right here. 4, 2 is right here. 5, 4 is right here. 6, 6 is right here. Okay, 7, 8, I don't see. It would be right here, but I mean, it follows the pattern. So did it work? Yes. So it definitely worked. So this is our inverse. Okay. Now, another way to always find the equations, which we'll talk more about later, is if we plotted the points, if we found this, couldn't we do stat, put it in stat and do stat right 4 for linear? Yeah, we definitely could. Okay, so so these are both linear. So this one's linear, we'll label, and this one's linear. But look down here, the original, what is that? So remember, when it gets really close to the x-axis, it's exponential. Okay, and then whenever it gets really close to the y-axis like that, remember that's a logarithmic. Okay, so remember we wrote on our notes page that those are opposites. Okay, so pick a few points. Let's find pretty points. This is a pretty point. This is a pretty point. Okay, that's about it. So this is 0, 1. This is 1, 2. This is 3, 4. So one thing I want y'all to remember is that x is your side to side while y is your up and down. Okay, so this went side to side 0 and up 1, side to side 1 and up 2. Okay, that's how you always find these. So let's flip them. 1, 0, 2, 1, 4, 3, and see if they work. So 1, 0 is there, 2, 1 is there, 4, 3 is there. Did it work? It definitely did. Okay, so again, here's your oh my gosh, inverse, sorry, and there's your original. Okay. So number 3, I'm going to let y'all try. So I want y'all to try number 3. So all of y'all should be trying right now number 3. Okay, so let's find some points. So here's a point, here's a point, here's a point. Those are really the only pretty points. Okay, so that's negative 2, 2, 0, 0, and 2, 2. So really only one of these is going to flip. Okay, so it becomes 2, negative 2, 0, 0, 2, 2. So we already know that the 2, 2 is there, the 0, 0 is there, and here's the 2, negative 2. So it definitely worked. Okay, there's my inverse. Again, it shows you how. Okay, we're going to kind of talk about those in just a second. So it says, how can we tell by looking at graphs if two things are inverse or inverses? So looking at the graphs, I want you to realize, so going back at these, I can plot the y equals x. Remember, it's just when they're equal. Cuts it directly in half. It flips over this yellow line I drew. Okay, so if you notice, this is up 1, 2, 3, like in a half, or look, we'll do a pretty point. 1, 2, 3, 4 is over 1, 2, 3, 4. So it kind of flips diagonally. Okay. If I were to fold my paper in half on that line, those two lines would be directly on top of each other. Okay, so again, when I draw my y equals x, okay, we have this line, and it's perfect the same on both sides, okay? And again, if you notice, the points that don't change are the ones that land on our y equals x line. I do want y'all to graph that. So on all your graphs, I want you to go through and graph the y equals x. Okay? Okay, it flips over y equals x. Okay, so when it says how can we tell by looking at the graphs if two things are inverses, I mean, there's really up to you. You could look at the points and flip them, kind of like we did here. You can just tell looking by drawing your parent function. So we'll say it flips over y equals x, and check points to see if x and y traded. Okay. So then it says how can we tell by looking at tables if two things are inverses? So this is pretty simple. Just making sure that x and y traded spots. Okay. So almost done, and you'll have a little bit of free time. Just looking at the equations. So again, remember, you swap your variables, just like we said on the notes page. And this you always swap sides, so that way y is on the right side. Okay, and it's showing you how. So the inverse of a linear is linear. That's one thing I want you to realize. The inverse of a linear equation is a linear equation. Now, this is an exponential equation, and we switched x and y. We divided both sides by 1. That got rid of the 1. Okay, and then we have this 2 to the y power equals x. So when you do log 2 to the y equals log of x, because remember, what you do on one side, you have to do the other. That y can move to the front. Okay, this is something we're definitely going to learn, so don't freak out. And then you'll divide both sides by log of 2, and then it leaves you with log of 2x. Okay. Okay, and then here, the inverse of squaring something is square rooting something. So we remember we flip, swap the sides. Okay, we multiply both sides by 2, and that gets rid of that 1/2. Okay, then we take the square root of both sides. Remember, the square root of anything squared, square root cancels squared. That's why y is now by itself. Also plus and minus because we don't know if that's a positive squared or a negative squared, so we have to make sure we have both. Okay, and there would be our solution. So these are definitely things we're going to talk about more. Go ahead and pack up. Be nice to the sub. I will be there on Monday. Promise, promise, promise. Okay? I will see y'all on Monday.